Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 2nd, 2025, about a week ago. The headline is clear. This paper argues that privacy risks in large language models are far broader than memorization, and a review of 1,322 privacy papers shows research attention is badly misaligned toward training data extraction. The paper is titled, Position, Privacy is Not Just Memorization. And as we'll see later, the implications for governance and deployment are quite significant. Beyond the critique, the authors map a lifecycle taxonomy, document risky provider retention and consent defaults, and sketch a technical and sociotechnical roadmap to mitigate real-world leakage and aggregation. Alright, the previous segment set up the lifecycle view of risks. Table 1 organizes the privacy incidents across 5 categories and 3 data types, so it shows where data comes from, who is harmed, who gains access, and what role the model plays. The rows span regurgitation, direct chat leakage, context leakage via tools and agents, indirect attribute inference, and direct attribute aggregation. The final column matters because the model shifts from data store to autonomous agent to inference engine to search engine. Alright, the previous figure mapped incidents across the ecosystem. Figure 1 shows how small interface choices quietly convert feedback into consent, which means conversations become training data without an explicit yes. The left panel highlights Anthropic, where a thumbs up or down opts a chat into collection. The right panel highlights OpenAI, where choosing a preferred response records the full exchange. These defaults magnify risk because users rarely notice, and retention windows can be long. Alright, the previous figure showed how feedback turns into consent. Figure 2 illustrates deep research exposing a pet name from a tiny comment hidden in an HTML tag, which is the kind of fact that often anchors password recovery. The left panel depicts the chat snippet that hints at the name. The right panel shows the source page highlight where the model surfaced the embedded text. This matters because small, innocuous clues can unlock serious account compromise. Well, the previous figure illustrated how tiny clues can expose a pet name. Figure 3 shows connectors that automatically pull data from external sources, which simplifies setup, but expands leakage paths. The left panel depicts OpenAI connectors that auto-reference indexed content unless users explicitly exclude a source. The right panel summarizes Claude nodes that exclude raw connector content, yet copied snippets still enter chats. Deletion remains messy because data fragments often require manual, scattered removals. So the previous figure showed connectors that widened leakage paths. Figure 5 presents the incident type distribution, and the pie chart shows 2 slices dominating, training data leakage at about 48% and direct chat leakage at about 44%, which together reach roughly 92%. The remaining categories are small, with indirect attribute inference near 6%, context leakage around 2%, and direct aggregation near 0.2%. So the big takeaway is simple. Privacy risks go far beyond regurgitation, with context leakage, agent behavior, and deep inference posing the sharper harms. The research focus is misaligned, which means deployment needs layered fixes, minimize data, move sensitive work on device, audit agents, and reform consent and retention defaults. Thanks for listening. I am Alex, and this was the AI Research Roundup.